So this is the first video looking at the 8080 processor card from my Heatkit H8. We're looking at a photo of it here, and I know it's somewhat difficult to see in the photos. It's not showing up well at all. You may be able to see this jumper here has been cut, along with this jumper down here has been cut. It doesn't show up well. So those are non-standard from what I believe are the factory settings on the card. There's definitely some mods to this card. We touched on it, I think, briefly in the H816 RAM card video. But I become curious about the modifications to this card. If we move on to the photo of the backside, you actually see the modification here. There's a dead bug style IC stuck on the back here and wrap wire going off to various places. It turns out this is a CD4050 level translator buffer. So it's really curious about why they'd be using that part on here. Obviously that part goes off to the edge connector here. And if you keep this bank of 4 jumpers right here in mind, when we go back to the previous video, this is this bank of 4 jumpers. These connect ground on through to a couple of extra pins on the edge connector. And what they've done is isolated those pins from ground by cutting the jumper links, and then taking output signals from him to the output pins. They've also, down here on what I believe are the interrupts, well, these are the interrupts, also done the same thing. And this is kind of weird and interesting. We'll look at this a bit deeper in a minute. But if you look down here, I missed this one. So C2 has been cut. C2 to B, or C1 to C2 and B1 to B2 are open, with the factory jumper link on C1 to C2 again cut. So what they've done here is they've added this 4050 on the back of the board. What is that? Yeah, I looked funny there for a second on the back of the board. So what I've done here is taken the schematic, kind of cut the section out with just the schematic itself. I've added part IDs in here just so I know what the device types are. I can see it's off the top of the screen here a little bit. Let me see if I can get it centered a bit better. So I know the device numbers. I've highlighted in green all the various jumpers on the machine. And this captures the as-built with the CD4050 mod. So we can look at this, if I can find them, and know that from the factory, I believe C1, C2 are jumper, and on my board they're open. So they've gone in and isolated the interrupt 10 and interrupt 10 and interrupt 20 signals, again going out to the bus. And they're picking up 4 signals off the board through the 4050 and sending them out onto the bus. So the 8080 sync signal gets pushed out. Oops, sorry about that. The 8080 wait signal gets pushed through. The phase 1 clock signal and the ready signal all have been added to the bus. So as the comment here indicates, edge connector pins 18 and 20 are disconnected from ground and pass those through, and then 8 and 9 are disconnected from interrupt 10 and 20 to pass through. So because with this processor card I actually had schematics and manuals, etc., I spent time to basically create some working documents so I can keep track of what I'm doing, and that's a bit of what we're looking at here. Luckily, yesterday I was provided a document that had the x-ray views of the card. And let's actually move past this one picture as we talk about this. So the x-ray view of the processor card. And in this case, I just prepared a document here that just has that x-ray view and captures the pin out, just to make it a little easier for me to identify what pin is what. If we step back to the one we were just looking at, this image has been flipped along the vertical axis here so that it represents looking at the card from the back side. So in this case, the solder side of the card is up. We're looking through the card at the ICs, and that's why I've left all the IC numbers backwards. Pin 1, of course, is as viewed from the back of the card, but the idea is to be able to get the CD, get lines drawn down to that CD4050, so I really understand what's going on. This actually isn't the image I wanted to bring up here. Just looking at the images I've created, here's another image that captures the pinout of all the devices with the way the board's wired. I've been able to identify that there's the P1, P2, P3 jumper here. There's actually another jumper here that's not labeled. And that jumper jumps IC214-pin 14 to IC219D-pin 15. It's shown that way in the schematic with the jumper. It's just unlabeled. So I captured that detail here. Let me go look for the photo that I actually apparently don't have here. It's going to be not that one. This one right here was another one that I went ahead and drew up. And what I've done here in this case is I've again got the board view backwards, and I've added the CD4050, and it's displayed on here dead bug style. So it's like I'm looking at the bottom of the chip and the pins are standing up. But I'm going to go back in this video to my continuity tester, and I'm just going to validate the wires go from here to where I think they do on this card based on my first pass through. But this will be a validation of that, and it'll also capture exactly how this device was wired in. So that'll be useful as I start to investigate. So the question on the forum was, what is this chip doing? My only guess, and I haven't proven this yet, is because the system came with an S100 card for memory plugged in, and somebody has hand-built an adapter card, that perhaps these signals are required on the S100 card. Like I say, I need to dig deeper into that to verify that. I got other things in here worth looking at. I broke the schematic out in a couple of pages. It blows it up, makes it easier to deal with. We just looked at this image. There's the raw flipped. But the point here is I'm capturing multiples of these. So I have a place to work from. We saw this guy. This gets into the other thing I wanted to talk about here in the video, is this K1, K2, and K3. On the silk screen, it shows K3 at the top, K2 in the middle, and K1 at the bottom on the silk screen. However, the original X-ray view looking through the card had K3 on the bottom and K1 on top. I've actually modified this X-ray view to show it in the same orientation as it is on my card. And looking at the schematic, K1 to K2 are jumpered, and it is jumpered on the card I've got. So I really think the X-ray view that was in the manual was incorrect here. So it's a bit of a errata to keep in mind. And of course I've labeled this telling why I made this change. So again, that's just something to keep in mind if you're going in the kind of detail I am here to understand the card. I spent a lot of time comparing and looking, and uncovered really that I believe the X-ray view there is incorrect. So we talked a little bit about this processor card previously in the video, and I'm going to go ahead now and go through it with the continuity tester and just verify that the way I saw the configuration of this dead chip style add-on here was done. There's actually a couple other things on here. There's this jumper wire here that I don't understand yet. I thought there was one other, but maybe not. So anyhow, as I showed in the previous video, I've got this X-ray view of the board. I flipped the X-ray view over so it represents the back of the board the way we're looking at it here. Makes it a little easier to keep track of where I am as I'm drawing in connections. I've got the pinout here of the CD4050. It's also flipped, so we're looking at it from the bottom. Just makes it a little easier in trying to translate this in my head in real time. Don't know how exciting this will be or not, watching me kind of go through this, but we'll get it done, and then I will cross-check it across the job I did earlier, just to make sure I've got everything correct. My ultimate intent here is to remove these mods and get this card back to factory. Apologies for Rosie in there. So we have a connection right here to pin 1. You can hear we have continuity, and that is power, and I'm assuming that's +5 coming into this, or the +5 volt rail. I don't actually know that. And so what I can do here is get on one of the TTL devices. So I have, I believe, a TTL device here, and power should be right here, +5. So that tells me that that is +5 coming in there. So this isn't doing like a conversion to 12 volt levels or something. So that's something I hadn't verified before. Trying to decide whether to use Sharpies to do this or pencil. I have to shift glasses around here to see if these are better. So that's coming from this capacitor right here off of this pin. So that's the same as it was before. I don't remember where the board picks ground up from. We do know that ground is over here on pin 8. And it's this wire right here. So we have a wire from let's see, where was that to? I was just following that and lost sight of it from right here. So we have a lead that comes from right here to pin 8. So we know we have ground there. If we get over here on the edge connector to pin 24, it's one of the red wires. Can't really see through the bundle here. There it is. So pin 4 comes over to right here. And actually, I've got what I'm drawing here off camera. Most likely I'll slide everything up a little bit, because as always I didn't make a very straight line there. We got this pin here coming off on a blue lead to pin 2. Pin 2 is coming up to, I can see here now I drew through where I need to connect that to, so we're going to erase this line. Pin 2 is coming to right here. Actually, I didn't draw that through where I wanted to connect that to. That line was okay, but that is what it is. We've also got, see, that was the 2 grounds. We've also got a lead coming to B1 right there, which is right here. It's one of the blue wires. Oh, got lucky that time. It's this guy. Sure, yep. And then we have C1, again a blue lead. Pin 10. So there's a wire coming from here to pin 10. And again, this is all as I remember it being. Now we need to find the inputs for these. Oops, that's not a probe lead. One of the inputs is right here. That's 2A. That was that pin up there, right? So that is this pin right here. And I've also got this pin right here. So let's draw this kind of down out of the way. And he's to here. We've got that pin someplace to a blue. It's up here on the pin 9. We've got pin 7 here. That runs up to H1. I'll just draw him up through this way. And my angle's way off there. To H1. We have one pin left, which is pin 3, which must go off to where? I'll bet it's to right here. So that is 4 pins in on here. 1, 2, 3, 4. So we've pretty quickly worked through this. There was this extra connection up here, which has been kind of confusing, from pin 3, or the third pin up, to this pin right here. And I don't really understand that connection. I'll have to come back to the schematic and look at what's being done there. I think that actually is very consistent with how I remember, again, going through this before. But what I want to do, like I said, I wanted to get a better drawing here to do this on. And then I will go back to the original image of this and I will draw these in a brighter color, or set of colors so they make more sense. Probably a single color for each signal set. But while I'm here, I'm curious about IC209. It's a 74LS240. It's got a jumper from pin 11 to 8. Is that correct? Yeah, 8, 9, 10, 11, 12, 13, or from pin 10 to pin 13. So 1, 8, 10, 11, 12, 13. So pin 1, or pin 10 to pin 13. And that is this guy. So there's a jumper going from pin 10 to pin 13. We know here, based on the drawing, pin 10 is ground, and 13 is an input, obviously. So the question is, where's this output going? Is there something else I've missed here? Was this an unused gate? Or are they just forcing that signal to always be low? 12, 13. So 13. It's running from here to 13 up there. And the output of 13 goes to pin 10987. So that pin is essentially being forced to be always high, and that just doesn't make a whole lot of sense to me why that's needed. Really doesn't make a lot of sense. I do not see a trace from that pin that goes anywhere. Just really curious. Let me get a look through the board here, get the light through the board. I really do not see a trace that goes from... Is there a via both directions there? Yeah, see, the X-ray view differs from the board here. On the board, that trace comes out to a via here that goes nowhere. Let me make sure that's actually electrically correct. And it is. To a via that goes nowhere. So that pin was just floating originally. And what they show here is that coming to a via that comes in that went to ground. Oh. So the question becomes, I should have brought the schematic up. Is this a factory mod? It's too clumsy to have been factory. Because I do see a hole there, and by red that would be on the top side, and of course we can't see down through there, and I believe the socket's a full-bodied socket. I'm going to block my view, although I'll pop the device out. If I can, just to see if I can see down through. I can see down through, and I can see that the via there does exist down in there. I can't really push the probe tip down into there to get to it, because I'd like to own that out. Okay, I can get that little jumper there down in. So there's really just three. That's really weird. Three. Is that just to keep that pin from oscillating, maybe? You know, maybe the... I guess there kind of is a very gray. It's just hard to see. I believe the board is consistent now that I've looked closer with what I'm seeing in the X-ray view. But again, that doesn't seem to run off to any place. It's not shown running off to any place. And its output, so on pin 11, 12, 13, and its output is on 10, 9, 8, 7. 10, 9, 8, 7, and 7 again appears to go nowhere. Looks like it just runs off to this via right here, which it does, and that via is right there, and it literally doesn't go anyplace. That's interesting. I can only surmise from that this was simply done to ground the input to this bus driver here, just to keep it from oscillating. If you leave a TTL input floating, it's supposed to pull high, and it typically will, but you can get oscillation. And maybe there was just an issue here with, maybe this was just a recommended mod. I found nothing about it that was put on here, but it's just an extra inverting bus buffer, an extra 240 gate. So I don't know that has anything to do with anything. Another comment that I want to make on here, based on what I saw on the forum, is X1 and X2 are not jumpered here. It doesn't look to me like they've ever been jumpered. If you had the Org0 mod in, these would be jumpered together so that the expansion card could disable the ROM on the card. This brings the ROM disable, I believe, through. ROM disable comes up through here to the X1. And so the ROM's always enabled on this card, which is further evidence that it doesn't run in the Org0 mode. The question was, with the 64K S100 DRAM card in place, had this somehow been reworked to basically do the Org0 emulation, where the ROM contents copied to the SRAM or the DRAM card, ROM disabled and run out of RAM? And no, the ROM disable is not hooked up, so that's not something that was trying to be implemented here. I've said it several times, and I'll say it again. I still suspect that this has something to do with the S100 RAM card. That's going to be a fair amount of work to go through. I've got the S100 RAM card here. I'm going to have to basically get in here and see if those signals are brought in, and I guess I can do that. While we're here, just because it's kind of investigating the same thing. So there are grounds. Figure out which bus is which here. That should be ground. Pin 7 to 7. The pin out of this device may be oddball. Anyhow, I'm on what I believe to be a good ground. Multiple devices where ground should be are there. If we look at these two pins down here coming in, they should go through the ground, and they do. If we come up to pin 18, 24, 23, 22, 21, 20, 19, 18, it doesn't go through the ground, and it shouldn't. And the pin 24, so both of those have been floated on the 8080 processor card, and they used to bring other signals in. So the question becomes, there is a wire wrap off of 24, and there's a wire wrap off of 18. And the question really becomes, where do those run to? I'm assuming I have an electrical connection there. That's coming in right there. So we know that card's being, we know that signal's being brought onto the S100 card, and we know it's not connected to ground. So I think it kind of says what I was surmising is these signals were required by this card. Sorry, interrupted by a phone call there. Pin 20, 19. Let's get back on pin 18. I think we just found it along here someplace, or maybe not. I am making it onto the car through the connector there, so it's got to go someplace here. It may actually come someplace on there. Apparently not. So it also comes onto the edge connector. If we get up here to pin 9, there's 10, 9, that's another signal they've brought across. If we come down to pin 8, so this is interesting. So they are buffering those signals via this chip, and they've removed the original function of those 4 lines. These were grounds, and this was interrupt 10 and 20. They're pushing these other signals through. They're buffering here, and those are coming directly from the edge connector to the S100 connector. They're not going through any of the buffers that are on the card here that I assume for all the other required signals. These are all 74 LS240s, which makes sense. So we have the LS240s on here. There's several of them that buffer the bus, and those are inverting buffers. Then the signals come in here to this set of buffers and are inverted again back to the original signal. These are non-inverting buffers. It's just a straight buffer, and so the signals are coming through clean, or all, they get to the the S100 card, they're all non-inverted. So I almost I don't know whether I would have. I just don't like this dead bug mod here. It's just kind of ugly. I might have picked a place on the card, like maybe up here. I don't know, it would have been hard to get over those 2 buses. There's not really a space on the card with enough empty space front and back to have drilled and mounted that chip a little better. I don't know. Like I said, I'll go back and confirm this and get it drawn up, but I'm 90% confident this is how it buzzed out before. I just didn't have a nice diagram to draw on to capture it. See, I do want to remove this, get the card back to the original configuration. I know in that state I won't be able to use this card. A couple people in the forum have commented that this, they've never heard of anybody creating an S100 adapter before. I'm going to have to look up my pinouts for the S100 bus. I assume these signals they have to be required or they wouldn't be here. Anyhow, I'm going to wrap this up at this point and hopefully keep this video nice and short. And as I have more, I'll throw another video up. I will try not to do a whole series of long boring videos like I did on that H816 RAM card. The lack of documentation when I started the process on that really drug things out. Anyhow, so I just spent a bit more time looking at this red wire that we were talking about just a second ago. It goes from ground to this input on the 74LS240. And in looking at the X-ray view, so we're looking at the same device right here, and that red lead is running from right here around to this pin here. And looking at the X-ray view, we can see that there's that pad that goes nowhere that goes to that pin. Is that correct? Why does this seem incorrect? No, this is correct. So we've got that lead that goes from ground to right here to this pin 11, 12, 13. And we can see on the back side of the board we've got a via with copper that runs to the device pin, and then on the top side of the board copper that runs to a via that then passes through to this ground connection back here. So that pin is meant to be grounded based on the circuit board design. And then looking at the circuit board itself, I can basically see that to be true. We have the pad out here that's just not connected anywhere to the device pin, and then on the front side of the board there's copper that runs to this via right here. At the moment I'm wondering if perhaps this plate through failed, and so this didn't get pulled to ground. I can't see through the socket to see if somebody had done a trace cut here. I see no evidence looking at this device that the socket's been removed and resoldered. There's no additional flux or anything. It's very similar to the other sockets. I'm assuming this is a factory built board. I don't know if they were all factory built or not. I know they were originally. So kind of what I'm surmising here is that perhaps the plate through here had failed, and this wasn't being pulled to ground, it was pulling itself high, and that was causing perhaps oscillation or some other issue. And the quick fix was just to tack it to ground via this little red lead here. Because this via is ground, this via here goes nowhere. This is the input of the buffer, and then the output comes up to here. And again, this pad goes nowhere on the back side of the board. And if we actually pull it up on the front side of the board, let me pull up the front side photo. We've got the front side photo here. Let me scroll over so we get him in view here. We've got the front side photo here, and that output that we just saw comes to this pad right here, which again you can see there's no copper that goes off any place. The X-ray view doesn't show this going anywhere, just connected together. So I'm surmising there was a pad on both sides put in just in case you needed to use that buffer for a mod. I don't know that for sure, but that would make some sense. Perhaps in this revision of the PCB, that ground connection in there has been removed, and that's why this pin was floating. I just don't know, but I'm convinced that that lead, that this little jumper has nothing to do with the CD4050 mod on the board. So anyhow, I just thought I'd throw that in. I don't think there's anything else really interesting to look at here. I've gone over the photos and the board pretty closely, and I'm not seeing trace cuts anywhere. With how this works out in the schematic, I don't see any need for trace cuts. The only kind of cuts that do exist are, get these in frame. Actually, I went the whole wrong direction there. The only that do exist, let me slide this over so we can see the whole thing, get it in the screen capture here, is this jumper here and this jumper here have been cut. You can see this one poking up. This is isolating those pins that were ground out here to float them, and then the mod wires come in the back. So rather than trace cuts, they just cut the jumpers there. I don't know why I keep scrolling over there. I've been looking at the back side of the board too long. C1, the jumper here has been cut, not isolated one of the interrupts, and then the mod wires coming to this pad right here. And because this B jumper is not factory installed, the other mod wire comes to here. So really the only three, I believe, non-factory modifications are the cutting of these jumpers.